Hi again. So with flu season being in full swing, have you ever considered what the molecular nature of viruses are? Or have you ever wondered what were the forces which allowed the formation of the original occurrence of life on this planet over 3 billion years ago? At a fundamental level, these phenomena are based on the broad principle known as biological self-assembly. As the name implies, these are systems which assemble into defined structures without guidance from an external source. As stated above, this kind of self-directed mechanism is critical for the development of living organisms as well as the propagation of viruses. And furthermore, through understanding the principles which govern this kind of assembly, we are learning how to build systems with applications which touch almost every field, from alternative energy to materials fabrication to the development of new drug delivery technologies and clinical therapeutics. As a simple illustration of this concept, consider the following demonstration. Here we have a pie tin filled with water. We can add a floating magnet to the dish and notice how freely it moves about the space. As we keep adding more magnets, keeping their poles all oriented in the same manner, notice how the system begins to spontaneously arrange itself into an ordered structure, first adopting a hexagonal arrangement, but eventually configuring itself into a more compact cubic packing arrangement once a sufficient density of magnets has been achieved. Now, that may not seem like too much, but a similar kind of process is what helps viruses easily reproduce themselves in their host, which are often you and me. You see, viruses are relatively simple complexes of protein subunits which self-assemble into a shell which contains the viral genetic material. However, instead of bulk magnetic repulsion, these proteins assemble via non-covalent molecular interactions such as hydrogen bonding. You can imagine the assembly occurring in a fashion similar to this. With respect to the original occurrence of life, the fundamental currency of information upon which all life relies is DNA, a double-stranded molecule which forms via complementary base pairing interactions forming favorable hydrogen bonds. Even more, these DNA molecules must be encapsulated within a lipid membrane, a feature of all living cells, and another structure which self-assembles. This lipid bilayer forms in much the same way as we saw with the surfactant layer in the magic milk experiment. Part of the beauty of self-assembly is in the fact that these structures, often being driven by thermodynamic pressures to find definitive energetic minimums, arrange in perfectly defined structures with little to no imperfections, a critical feature in designing nanoscale materials. Recall graphene synthesis from the S&T log. With respect to protein assemblies, these biologically friendly structures are being explored for their potential applications as drug delivery vehicles with the ability to deliver payloads to specific tissues, such as malignant tumors instead of healthy cells. This is a relatively new line of research, and much of it is happening here in Los Angeles at UCLA. One day, you and I may be injected with self-assembling nanomachines to cure all our ailments. Won't that be something? That's it for us. I'm Justin Scott, your Transit TV Science Genie, reminding you to always ask questions.